In this session, we are going to understand the ephemeral containers concept in the Kubernetes, and I will explain you the complete practical implementation of a ephemeral container for the debugging purpose. And we will understand the syntax. There are some core concepts associated that we must know how to use this in your practical life. So let's start. I have this Kubernetes cluster and I created this manifest file just to create a pod under the deployment, and it is using a simple Nginx image. So I will run this pod and then I will show you what are the issues we can face in our professional life where we need the ephemeral container for the debugging purpose. So kubectl apply kubectl get pod is created under the deployment kubectl describe this pod. This pod is running and this pod does contain the nginx container. Okay, now if I want to jump into this container, the container of this pod, so I will use execute hyphen it, and after the double hyphen I can run bash, and I will jump into the terminal of the container and I can run ps command to see the processes, but ps is not there. So I cannot troubleshoot related to the processes issue. Similarly, if I want to ping command is not there, ns lookup is not there, netstat. So all the commands related to our troubleshooting for the network related or anything else are by default not available in our container, because our container is made of to serve, to give us the services for that specific process that we created. It's only created for the Nginx. So how we can troubleshoot? And one more thing very important, in professional life, mostly for the security purpose, we are also not installing the binary. I mean, we are removing the binary of bash and sh to avoid any command line interaction with the pod for the security purpose. So the container is not reachable by this way. So then how we can troubleshoot such type of container? If that container is running fine inside the pod, how can we interact and how we can troubleshoot? So here Kubernetes give us a debug feature where we can apply the debugging. And if I just run the help, you can see all these arguments we can use uh, with this debug command. So here I will use, first of all, let me get the pod again and then I will debug. Then IT is for the interactive connection with this pod by using image, and you can see this image container image to use for debug container. So this image will work in parallel to our actual container running inside this pod for the troubleshooting purpose. And what image I can use? I can use any image that does contain our required binaries and whatever we need for the troubleshooting purpose. Here, just to show you, I am using Alpine because I know Alpine default image size is very small, and second thing is it does contain ping, NSLOOKUP related tools. So I will show you. So now image is there, and now a hyphen hyphen target. So what is this target? Which container we are going to target from this pod? and I showed you the container running inside this pod is Nginx. Okay, so I want to hit this container inside this pod, and I will take the leverage of terminal of Alpine, and this Alpine container will be able to see its file system, will be able to see its processes, and will also help us to troubleshoot with the help of additional binaries provided by Alpine image. So I will press enter, and here you can see debug container is created with this name. So now if I go to another terminal, and here if I run kubectl get pod kubectl describe this pod, sorry, this describe this pod. So this pod does contain Nginx and Ephemeral container with this name. Okay, and it's using Alpine image. Okay, now if I do ping, I can test the network connectivity. Okay, I can do NS lookup. Okay, I can do telnet. Telnet is not available. So you can make your own image, any default image that contain your required binaries. So, and ps command is showing us the processes of the Nginx. So Alpine image does not contain this process, but these processes, process ID 1, 29, 30 is coming from the Nginx image that we defined as a target, and process ID 41 and 47 is actually running inside the Alpine image. 41 is the terminal that we are using, and 47 we just ran for the PS. Okay, so now this way we can do the troubleshooting. Now the question is, how can I troubleshoot for some file system, or I want to see some file system inside this image. So it is not straightforward. It is mounted under the proc, and you can go into the directory created for the process ID under the proc, and here is a directory name as root that is in fact the root file system of Nginx image, because this process is running with the process ID 1, and this is running by a root user. And here if I do cat and not forward slash, because right now I am in the forward slash, this is a forward slash of the Nginx, so I can do etc nginx nginx.conf. This is the configuration file. Similarly, I can see usr share nginx HTML nginx index.html. This is the default page of Nginx. And if I want to do any modification, I can do VIM. I think not available. VI is available by default in. So here I can make some modification, mm, edit it by using debug container. I just modified this. I'm going to save it. It's saved. So just I'm doing cat, you can see it's modified. So with this way we can access the file system. Okay, now again I'm running PS. I can see two more processes are running by Nginx, and process ID 29 and 30. But these two processes are not running under the root user. These processes are ran by a non-root user whose ID is 101. So let's try to hit 29 directory, and here do ls, and here we are looking that this root is permission denied for us. And if I try to go under the root, permission denied. Why? Okay, so why is this? First of all, I will show you who am I. I am a root user inside this debug container. What is my ID? My ID is 0. By default, root ID does contain 0 ID. But what is the reason I cannot access the root file system even I am a root user? So remember, in debug container, you must have the same ID. You must be logged in with the same ID that is going to hit some file system uh, of some process of some user of a process ran by a user. So process is running by 101, okay, and only 101 user can access it. So I will show you this one by creating another container, but right now just you should understand that the user ID should be same to access the file system of some specific process. So I was able to see the first process ID because that was running by root in the Nginx, and my ID was also 0, that user ID was also 0, that's why I was able to access. Now I am quitting from this container, and if I show you kubectl get pod, kubectl describe pod, so you can see here the container is running. Okay, I showed you, but the another thing we have now to understand about the ID difference. So for that reason, what I will do, let me kubectl get deployment. I will delete this deployment, and I will modify this deployment with another image. This is an image that will run the Nginx but with a non-root user. So let's start this container by using this deployment. kubectl apply -f kubectl get pod, uh, get pod. The pod is running. Kubectl, let me do the execute. Kubectl execute -it this container -bash. I will enter into this. I think it does not contain bash, it contains sh. And if I run the id, this is an nginx user. Who am I? This container ran by nginx user that contain 101 id, and its processes, I think, yes, ps is there, is process id 1 30 31. These three processes are running by this non-root user. Okay, let me exit and think like I don't have bash and I need to troubleshoot this container. So how can I do? I will do the debug, and then I will provide the image for the debugging like Alpine, and then I will provide the target. Okay, the target image name, container name is Nginx, and press T. Sorry, target spell is wrong. Target. Now I am creating an ephemeral container inside this pod, and now let me run ps. So ps, this time the process is not running by root. Last time it was root. Let me go to proc 1, the root, and permission denied. So now what is the solution? So solution is I should be logged in with the same user ID to provide the to access this file system. What I will do, I will add user. So use add user is a command in Alpine. To add the user, I will create this user with same ID. For example, I am going to create the user Asim. Okay, just putting some password for this Asim. Now I have this ID, and within the container, I will switch with this user. Okay, and now again PS, I will go to proc1 slash root, and I am able to see the file system because I am trying to access the same user ID. So ASIM ID I set same with the 101, that's why it's showing here the ASIM user. But actually it's running by the Nginx. And here I can do cat etc nginx conf and usr share nginx uh, and html index html. See, this is the file that we can that is the default web root file. So here we understand the concept of accessing the file system by using proc, and the id should be same. So how I did this, on the runtime I create the user. Okay, now this is done. So now I am going to exit from this debug container. We understand the concept, how to how to access the processes, how to access file system using same user ID. We understand these two concepts. But here, the practice that we use to debug the container is not good because now the ephemeral container will remain lifetime with this pod. So it should not be. And in case we did some mistake during the troubleshooting, will actually affect the actual container running, actual application, actual container that is right now in the production. So what is the workaround? The workaround is we should debug with, let me show you, debug debug hyphen hyphen help. So we should use, if we are using target, it will apply on the same, but in the same pod. But I will use copy to and share processes. So instead of using this one, share processes to true and copy to. What is this copy to? Copy to is to create a replica pod of the of this pod and then do all the troubleshooting. So this Alpine container now will run in a replica pod. Okay, and here I can give some any random name, debug one, just random name I gave. So from another terminal, I want to show you the kubectl get pod. Another pod ran with the copy of this pod that contain the actual Nginx image as well as the image that we added in this pod for the troubleshooting purpose. So here, if I run ps, okay, I am connected, and this time the process ID is 7, and I can Same behavior I can use, but I cannot, I cannot enter in the proc 7 root because I am logged in with a root user. Its ID is 0, but its ID is 101. So I hope you understand this concept. So now this is the actual, this should be your process of debugging any container in your production environment, so that your actual the container that is in it, that is providing the service in production should not be disturbed. Okay, now this is done. So we have to understand one more concept. For example, our deployment does contain multiple containers. For example, I'm just copying and I am running another container within the same deployment, just like Tomcat. And in within that same container, same pod, we cannot run two containers with the same port. That's why I use Tomcat. Tomcat will use port 8080 and this is port 80. Okay, so now Tomcat will run along with Nginx, and we have to understand how debug will help us to debug these both containers. So let me just save it and kubectl apply kubectl get pod get deployment and get pod. So new pod is created, and let me just first of all clear this debug pod. So deployment is there, but still there is only one container running. Yes, there are two containers. So one out of one container is ready, and this it's one out of one pod is ready, and this pod does contain two containers. One is, if I do a kubectl describe pod, so this pod has Tomcat and Nginx. Okay, now let me kubectl apply, kubectl debug -it this this pod with image alpine, and the target container can be Tomcat or Nginx. So let me hit Tomcat. So now if I run PS, you can see the Java process, the Tomcat is running inside for the troubleshooting purpose, and the Alpine image is showing us the relevant. If I exit, if I do a debug for Nginx, okay, so this time the PS is showing the processes for the Nginx. So with this way we can attach with relevant container for the proper troubleshooting. Okay, now if I want to use the previous method what I use, the share process and copy to. So share process with the same, just this ID, pod ID. This is the name of the pod. This is debug image. Share process will share the processes for all the containers running inside this pod, and it will create a copy of current pod. So now if run get pod, now you can see debug is created 3 out of 3 because now the ephemeral container is also running for the debugging purpose inside the same pod. That's why it's 3. And now if I run ps, so you can see Nginx and Tomcat both processes you can see. Okay, you can access the file system for the Tomcat, but you cannot access the file system for the Nginx. You must have to create the user with this ID and then switch to this user, and then you can access the file system. So a debug is providing you a process of debugging all the containers within a pod. So I hope you got the idea. If you have any question, you can leave me in the comments or you can write me the email. So this is done for this formal container in the Kubernetes concept.